In this video tutorial, I want to talk about solution stoichiometry, and I want to walk away from solid phase into aqueous phase. When you have solute, usually a salt, ionic salt, sometimes a covalent molecule, dissolved in a solvent. Our universal solvent is water, H2O, and state of matter becomes aqueous, and you represent it by AQ. Now, solution has a property which is concentration. Now, concentration is simply moles of solute over volume of solution. Now, the way I learned chemistry, volume was liters, but IB doesn't like liter. Instead, what they use is decimeter cube, sometimes called dm cube. So I want to stop for a second and just dissect this and make sure that from now on we are going to use dm cube instead of liters. We all know that 1 centimeter cube is same as 1 milliliter. We also know that 1000 centimeter cube is equal to 1000 milliliter, which is equal to 1 liter. Now let's see what else we can do. 1 decimeter dm is rather 10 centimeter. We all agree on that. Let's just cube both sides. So if I cube this side, left hand side versus right hand side cubed, 1 cubed, simply let's just write it as 1 cubed. dm cubed, decimeter cube becomes decimeter cubed. 10 to power 3, let's just write it as that. Centimeter cube is centimeter cube. Now 1 times 1 times 1 is 1. dm cube stays as is. 10 times 10 times 10 is 1000 centimeter cube. So 1 decimeter cube is 1000 centimeter cube. Therefore, we should agree that 1 dm cube is simply 1 liter. So from now on, instead of liter, which I'm really used to and I like, I'm going to walk away and walk into decimeter cube, or called dm cube. Now let's just solve some problems, remembering that concentration is moles over dm cube of solution. So we go to the next slide, and I have few questions prepared. Let's say I have 98.4 grams of iron 2 sulfate dissolved in 50 cm cube of solution. So this is solvent in addition to the minute amount of solute. What is concentration? I know concentration is moles over dm cube, or volume of solution. Let's have that. One thing I don't have is moles, so I have to find moles, and I know moles is simply mass divided by molar mass. So in this case, let me reiterate, this is capital M for molar mass. I have 98.4 grams of FeSO4. Now molar mass of this compound is, you have 1 iron, which is 55.84, plus 1 sulfur, 32.06, plus 4 oxygen, 4 times 16 grams per mole. So this is 98.4 grams divided by, once you sum this up, it's 151.9 grams per mole. When you do the division, grams cancel each other out, and you will have 0.648 moles of solute. Now let's just plug it in. Now the volume has to become in decimeter cube. So what you need to do is divide by 1000 or move the decimal place 3 decimal places to the left. So concentration is simply 0.648 moles divided by the volume in decimeter cube, which is 0.050 decimeter cube. You do the division, and it comes to be 12.9 moles per decimeter cube. Written as decimeter to -3, just bring it from denominator to numerator. So that's a typical question. One other question which is extremely important, immediately you have to find moles, and usually we give you the volume and we also give you the concentration. In this example, you have 25 centimeter cube of 0.1 mole per decimeter cube of sulfuric acid. Now, if you go after this ratio of concentration is moles over volume, so moles should equal concentration times volume in decimeter cube. So moles is equal to 0.1 mole per decimeter cube. This time I wrote it in the denominator times my volume, which I'm going to take it 3 decimal places to the left. 0.025 decimeter cubes. The unit decimeter cube cancel each other out, so final answer is you have 0.1 times this, which is 0.0025. You can put a 0 to have 3 significant figures. Zeros to the left are not. Moles of sulfuric acid. So this is final answer for this. Many occasions immediately you have to find moles because stoichiometry is based on moles. Now one other question I want to talk about is neutralization, which is when you have an acid and a base reacting with each other. 28 centimeter cube of sodium hydroxide, which is a base. So for those of us who haven't done acids and bases yet, this is a base. Reacted with 25 centimeter cube of 0.1 mole per decimeter cube of sulfuric acid. So it's the acid. What is concentration of NaOH? Now let me write the equation. Let's balance it together. So we have sodium hydroxide, NaOH, plus H2SO4. It's diprotic. It has 2 hydrogen that it can lose or ionize. It usually gives you a salt. The first name of the salt is the metal, and the last name is the polyatomic ion. So you have Na2SO4, sodium sulfate. You always also produce H2O when acids are added to bases. Now, in order to balance, I have 2 sodium, so I just put 2 NaOH. And on the other side, you have 4 hydrogens and 2 oxygen extra, so it's 2 H2O. Now, the states of matter, this is aqueous because you have a concentration associated with it. This is aqueous, another solution. This is aqueous until you dry it out, and then you have solid salt. The only liquid we have is H2O. Now let me just write attributes or properties that I have. Concentration of the base is challenged. So for NaOH, if you don't mind, I write C subscript B for base, and I put a question mark. I need to solve for this. Volume of the base is given to me. It's 28 centimeter cube. I'll do the same thing for the acid. Concentration of the acid is 0.100 mole per decimeter cube. Volume of the acid is given to be 25 centimeter cube. Now, first thing I'm going to do is find moles of my acid. So moles of acid, I'm going to find, then I go after balance equation, find moles of base, then I'm going to just divide by volume and give you the concentration. So let's just do that. So first step is let's find moles of the acid. Now concentration is moles over volume. We agree on that. So moles is nothing but concentration times volume. Let's go after concentration of our acid, which is 0.100 mole over decimeter cube, times volume, which is, I take it 3 decimal places to the left, so it's 0.025 decimeter cube. So times 0.02, sorry, let me just erase this and write it gently, slow down. I'm telling myself, so it's 0.0250 decimeter cube. They cancel each other out, so we'll have moles of acid being equal to, let me just multiply it on the calculator, and I have well, I don't need a calculator, just it's 0.0025 moles of sulfuric acid, H2SO4. So this is our first step. Now the next step is I need to go after balanced equation, which is 1, to 2, find moles of NaOH. It's twice as much. You can multiply it through. Once you have that, then divide it by the volume. Of course, change it into decimeter cube. So let me do that. So I start with 0.0025 moles of H2SO4. Just like old stoichiometric other videos I'll go, there is 1 mole of H2SO4 for every 2 moles of NaOH. You could have done it without this step in your head or just on paper, easier. So then you get twice as much, which is 0.0050 moles of NaOH. So we are almost there. I have the moles. I also have the volume. Simply concentration is moles over volume. So it's 0.0050 moles divided by, take it 3 decimal places to the left, so 0.0280 decimeter cube, and this division yields 0.179 mole per decimeter cube of NaOH. Final answer. This is neutralization, and the process in laboratory is titration. Quite often you do that. It's as soon as you find moles, then you can go back to what you know about stoichiometry and you're just fine.